In this video, we will learn about the slutsky equation. So basically, it tells us that change in price of good along an ordinary demand curve can be decomposed into substitution effect and income effect. That is, total effect of price change is equal to the substitution effect minus income effect. Okay. So, given a utility level U bar at the optimal maximization point, this condition should hold. That means the compensated demand for good X should be equal to the ordinary demand for good X. Compensated demand for good X means the Hicksian demand for good X. Okay, so I can write the compensated demand for good X is, and let me write it in this fashion, that is X superscript C. That means compensated demand for good X, which is actually the function of price of good X, price of good Y. Okay, holding utility level constant. Okay, that is the Hicksian demand curve. It should be equal to the ordinary demand for good X. Okay, ordinary demand for good X means the Marshallian demand for good X. Okay, and let's denote it by simply X. So X denotes the Marshallian demand for good X, which is actually the function of price of good X, price of good Y. Okay, holding nominal income constant. Okay, this condition should hold at the optimal maximization point. That means the Hicksian demand function should be equal to the Marshallian demand function. Okay, now as I told you, M denotes the nominal income, or we can also say this is the minimum expenditure. This M denotes the minimum expenditure required to achieve a certain level of utility, that is U bar. Okay, so in place of M, I can also write the expenditure. Okay, so in place of M, I can write the expenditure function, and we know expenditure is a function of price of good X, price of good Y, holding utility level constant. So I'm just substituting the value of in place of income, I'm writing the expenditure. So I can rewrite this, that is compensated demand function is the function of price of good X, price of good Y, holding utility level constant should be equal to, so we have X, which is the Marshallian demand function, which is the function of price of good X, price of good Y, and in place of M we have this expenditure function. So let me write it here, E, and expenditure is a function of price of good X, price of good Y, holding utility level constant. Okay, now what will we do? We will simply differentiate this function with respect to price of good X. Okay, so let us use the proper color here. So taking derivative of this Hicksian demand function or compensated demand function with respect to price X, that means the partial derivative of Hicksian demand function with respect to price of X should be equal to, now taking derivative here, the first derivative is the derivative of Marshallian demand function, that is dx upon dpx, change in the Marshallian demand with respect to price of good X, plus we have this dx upon de. That means since we have X is a function of expenditure and expenditure is a function of price of X, price of Y, and utility level, so we will be using here the chain rule, that is equal to, that is partial derivative of X with respect to expenditure first using chain rule, and times partial derivative of expenditure with respect to good px. Okay, now if we rewrite this thing here, and let's write it in terms of this that is dx upon dpx. Okay, it is capital X, sorry for this mistake, is equal to, so we have the partial derivative of compensated demand function with respect to price of good x minus we will have dx upon actually del x times uh, del e upon del px. I have just rewritten it in this fashion. So let's write it, rewrite it. So we have change in x upon change in px is equal to the change in compensated demand with respect to change in price, okay, minus del x upon del e, del x upon del e times del e upon del px. So in this place I can write x, only x. Why? It simply comes from the envelope theorem that tells us that let's write it here. So we have change in expenditure with respect to price of x is equal to x. Okay, how do we interpret it here? Okay, how do we give the explanation here? Envelope theorem tells us the derivative of an objective function with respect to one shift parameter is simply the partial derivative. Okay, so what is the you know the objective function here? So our objective function is the expenditure function. That means we want to minimize expenditure. Okay, we know expenditure is simply price of x, units of x, plus price of y times units of y. Okay, if this is our objective function, okay, if this is our objective function, envelope theorem tells us that the derivative of objective function with respect to one shift parameters, we have price of x and price of y as the shift parameters, but we are interested with change in the price of x here. Okay, so is simply the partial derivative. Okay, so the, and let me write it here, the derivative of objective function, that is the expenditure function here, with respect to one shift parameter, our shift parameter is price of x, is simply equal to the partial derivative. Okay, so partial derivative will be equal to, if we take the partial derivative of this expenditure function with respect to price of x, derivative of price of x is 1, so we will be left with x only here. Since no price of x is involved in the second term, its derivative will be constant. That is how do we get in place of del e upon del px is equal to x. Okay, so let's rewrite this. That tells us the change in Marshall demand with respect to price of good x is equal to change in the Hicksian demand function with respect to price of good x minus del x upon, so in place of expenditure I can also write the income now. Okay, these are the synonymous here, times x. Okay, so this is our Slutsky equation that tells us that total effect of price change can be decomposed into the substitution effect and income effect. Okay, so total effect, this del x upon del px tells us the total change in the demand of good x along the ordinary demand curve, what we call the Marshallian demand function, when price of good x changes is simply equal to the substitution effect, that is the change in quantity demanded of good x with respect to price of good x holding utility level constant. Okay, substitution effect is simply the partial derivative of Hicksian demand function with respect to price of x minus this del x upon del m. So this term tells us how much change in the purchasing power affect the amount we consume of a certain good. It is simply the derivative of Marshallian demand function with respect to value. Okay, and we multiply it with quantity here. Okay, I hope I make myself clear in this video. Thank you.